boring. You can do it. Every lab is now same structure. There is a how to run the first time, and there is also how to run the second time, and I'm running the second time. So if I'm running the second time, that's all I need to do. Let me do that. Let me go in my terminal into that place. What it says, you need to go into that repository, which you will have once you once you clone it to your machine, you will have all of them. Here they all are. And then I want to have the 35 one. So I just go into the 35. Okay. Now I'm in the right lab on my drive and ready to go. I should do the very first command. That command activates the environment, which I have already prepared for you guys. That is all. And when you do that, note that there is a 35. That's our virtual environment number 35, which agrees with the name of the lab. And then you just start the Jupyter. So start the Jupyter. By the way, do I have all the keys? They are usually stored in the .env file right here. Yes, I do. Sorry that I'm not showing what's inside, but that is following the best practices. So I can start. And before I play with that lab, I want to show you what I'm going to do, why it is important. Okay, for that, I prepared the next set of links right here. So we are in our AI webinars. And what is that about? I'll show you. So picture number one. Picture number one explains that, yes, it's great to have AI, but don't forget that there is keyword search. And so let's go back one step. Let's look at keyword search, and I think that's the best explanation I've ever seen. The keyword search does this. It takes in the text and it breaks it into words, which will be the same story for AI also. You take in the text and you break it into individual words or tokens, and then you simply count how many times did a specific word occur. For example, the word is occurred once. So if we're looking at a query which says what color is the grass, one of the things we're looking at is the word is and how many times does this word occur here. So you just go by the numbers. Then you look at what's common between this query and that answer. The query is what color is the grass, and the answer, the grass is green. So number of words in common. In other words, before there was one word in common, is between that question and that answer. Now there are three words in common, right? What color is the grass? The grass is, that's three words in common. So which of these queries, which of these answers is the best fit? Judging by the numbers, it is this one, right? Is there any better one? Judging by the numbers, it's no better than this. So what color is the grass? If you're lucky, the grass is green will be your answer. That is keyword search. But you see that in keyword search, you don't understand what's going on at all. And you don't even try to make any attempt. You're just counting the words. And if there are more words that are common between your query and then the potential answer, you choose that. So the database that they are going to use is capable of doing both. It can do keyword searches, and then it can also do the searches by meaning. So I think that's a wonderful explanation of counting the words. That is a no worse explanation, or maybe better, by counting the meaning. So what we do is we take all the words found in our texts and we convert them into vector in such a way that similar things occur in the similar place. For example, apple, banana, a little cherry, and strawberry. are all commonly considered fruit. Okay, so for the purposes of botanical classification or maybe legal classification, maybe some are vegetables, some are fruit, but they are close anyway. So we agree, and then if my question will be put to me about the apple, I will look at all the similar objects here, and they will be found here. If my question is about a car, well, I will be here, and so on. Okay, now this database is capable of doing that as well. You would have to store all your texts and store them with a key, and the key will be that, and it will come from what is called embedding. That's embedding, and it takes each word and converts it into meaning, with the end result that the vector that is representing this is usually 500 numbers long, 1,000, 1,500. That's the usual number. And then the database stores this. Now, when you're searching that database, you're coming up with the meaning. Okay, the next question shows you that the database that they use is capable of that as well. It stores them like that, but it also gets them like that. So if it's looking for what is the capital of Canada, then the one paragraph that is close in meaning is capital of Canada is Ottawa. Okay, and that's called dense embedding, because another name for those embeddings is dense vectors. All right. And finally, there is a little critique to dense retrieval. Okay, I can do that. My question is, what is the capital of Canada? And the answer is that it's right here. So it is maybe close to the question, the capital of France is Paris. And I might get a mistaken answer. I might ask, what's the capital of Canada? What I might get back is the capital of France is Paris. So what do you do about that? That seems to be better, right? Search by meaning is showing more potential, but it also makes mistakes. So for that, there comes yet another step not shown in this picture, and they call it re-ranking. So in the re-ranking, you will be able to rank them according to the meaning, and not just grab the very first one, but change the order of answers as they come, and that will be giving you precise answer. Okay, with that promise, I want to show you just a little bit of how it really works. So here you are. Let's look at lesson number 1. And I'll show you a few steps because it's important to understand what's going on. Okay, so what I do is I import the right packages. One of them is Vivier. That is a database that I'm going to use. That database is capable of either doing keyword searches or by meaning. And the reason this line works is because of the initial setup that I prepared, and that would be the initial setup. That's what I needed. Now, in that particular case, the lab is tricky, and these versions, at least for some people, they give you conflict. So what I did instead is I took those same requirements, took out the version. That was an advice given by the installer itself. Took out the version and it said, let it figure it out. So it figured it out. So if you're really going to do that lab, use this one. And that is a .sh file. Why is it the text? I don't understand. It should be .sh. Let's rename. Even though that renaming probably won't help, but for the show, I'm showing you have to run that as opposed to how you usually do it. But in the end, that's why it's working. It's working because I have imported all of them. Now, the Vivier key, there is an instruction. And the instruction should be, where do I get them? So it is in how to run the first time. And the very first time you run, we tell you which keys you need and where do you get them. So Cohere and Weaviate is easy, but API key. So URL is easy. What you need is Cohere key. So if you search, it will take you exactly to the place where you can get a trial key, and it will work for you for the first few times. All right, that's the nitty-gritty detail of all of that. But then we can try to run. Now I lost for a second where it was running. It was running right here. So if you did get all these keys correctly and even the URL, and that is a warning, deprecation warning, which is of course safe, and verify that your client is ready. Who is the client? The client is going to talk to the database. And if you want to do keyword searches, it will do it for you. It will give you what you're looking for. It will find the answer that is close by keyword count. And then the question will be, what is the most viewed televised event? But the answer will not be perfect because we're talking about lots and lots of text, and who knows if that is a good answer. So we can try, we can print, okay, like that, and it will give us a few answers, and actually one of them might be even right, but there's too much information. So that's how it goes with the keywords. But if you're going to do it with the search by meaning, then the first thing that you need to do is embedding. In other words, you need to take all your words and convert them to the vectors. So what is interesting in that lab is that you will see them. You will see those numbers. You will verify how true it is. Note that this load.env loads the .env file that was over there, but it's hidden because it's .env, and that loads all the keys. So if you forget that line, it will work all until where you really need the key. If you then come to the ask for the key and it won't be there, then it will give you an error on running. Okay, but now I'm taking some words, in this case, joy, happiness, and potato, and converting them to vectors. So joy should go with all the joy-related items. Happiness also, potato should go with all potatoes or other similar vegetables. And then you will be asking questions. That's what I was coming to. That indeed you get back representation of all of that in the meaning space, and that can be verified. That's even a live graph. So let's look. That represents where is the World Cup? That's the question. That represents the World Cup is in Qatar, and that's the answer. And they are very close in the space of meaning. Let's look at just one more. An apple is a fruit. That is a statement. And that is a question. What is an apple? And again, in the world of meaning, in the projection of our words into vectors, that's there. So if by now you think that, oh, that's too much magic, the answer is no fear, because you can clone the lab and try to run it and then modify it. You don't have to design all of that. That's already done. Now you're only dealing with let's run that. Okay, how much you can do. You see, it's even alive. That's fun. You'll have fun doing it. So then you do the dense retrieval. That is something that you can show how you look for things by meaning and not by numbers. And finally, you will say, I don't trust that approach either. And I want to rearrange, I want to do the dense retrieval, but then I want to rearrange the answers and find the ones that are closest by meaning. That's what you do. In the end, you will generate the answers. There will be a question. Are side projects important when you start to learning AI? For that, you will go to the writings of Andrew Ng. Would be ideal to grab the Andrew himself and maybe ask him these questions, but in the absence of that, we quote all of his writing. And then we ask the question as if asking the live Andrew Ng, and we wait for his answers. All right, I showed you what I wanted. I showed you that yes, you can take that data and you can apply regular keyword search with an explanation of why keyword search is nice, but doesn't give you the perfect answer. Then you use the same technology and the same database, but it can also do another trick. It can do search by meaning, and that is right here. And yes, of course, you would expect that Andrew AI will give you some nice answers. And you would expect that, yes, he will say, yeah, side projects are a good idea if you want to build a career in AI. Why? Because they can stir your creative juices. But there should be something more. That's an obvious answer that I couldn't invent myself. It talks about strengthening bonds with collaborators and potentially lead to something significant. Okay, but he gives other ways that are not completely obvious, something like that. All right. So now that we have seen that, I will really ask you a question. Before I ask you a question, I see there are two things on the chat. One of them, thank you, sir. It's wonderful. Is dense retrieval similar to the way RAG works or a different conceptual embedding retrieval? For that, and for that exact question, I have prepared here the continuation on our webinar. So that says that I'm showing you the cohere, the images, the demo, and now comes the question. All right, question. You're right, sir. It looks very close to a regular RAG architecture because let's look at that. What we're doing is keyword search. So we don't do keyword search in regular RAG architectures. But then on the other hand, it seems that the Weaviate and the Cohere don't do the keyword search in the end after all. They only use it for showing that keyword search is not perfect. And then they leave it, and now they go into embeddings. Now, for embeddings, that particular coherent demo uses a different LLM. It's called Aya, but it's also a big thing, and it's trained on lots of words. So we use usually embedding by OpenAI, and we then put the result in Pinecone. So that line is very similar. We use a different embedding, but embedding it is nevertheless, and then we put it into a database. Now on the left, it's the Weaviate database. On the right, it is Pinecone database, but again, database, vector database nevertheless. And then we do semantic search. So what is the difference? There must be some difference because what was the point of the whole lab? So I tried to figure it out. I thought the idea is this: combine the two. And I know a perfect use case. My lawyers, they were trying to use a RAG system, and they were trying to decide if the guy was drunk or no, and they were looking for a specific abbreviation of the test, and ChatGPT didn't say that, because that abbreviation, like RRA or something like that, that abbreviation was very specific, mentioned only once. Now, being mentioned once, it really shined on the whole document. But being that it is a question by meaning, it lost that one word. So I thought that they implement the perfect world. First, do the keyword search if you have to, then do the embeddings, and then ask for results. Well, I didn't see it in that particular example database. Now I think you see my question. So why go to all the trouble of Cohere and VBA? I found one answer. Cohere is dealing with languages much more than a regular approach would. They have 100 languages mixed in all together, so they can reason in any language, perhaps much better than ChatGPT. So that might be the use case. And that would assume that you have somehow very international company or very international storage, and that's a perfect use case. But I thought, how many people are like that? How many people know 100 languages and they read that same book in 100 languages, and now they're looking for help looking in them? Couldn't find it. So I asked ChatGPT, and I think I can find exactly ChatGPT here. Let's do it, and I hope it will store my conversation. So here, okay. So that was my question. What's the real difference? Well, okay, and they said if that's what you're looking for, you're comparing Cohere, which is embeddings, semantic similarity, and with the regular RAM. So what would be the difference? And I think it told me what are the perfect use cases. Well, here it doesn't do you traditional keyword searches, even though it's capable of. And it's powerful NLP model, powerful in the sense that it's different. So the question is, why do I use it? And enhance functionality by using semantic search, but that still didn't tell me what's so great. By combining that vector search with the Pinecone, you can create a robust system. Well, I read it a few times, and I still didn't quite understand what is so great. So honestly, you might have thought that I will give you the answer, I will give you a question, and then the answer. But you see, I did not enough work, but a little bit of work. And no, I couldn't find the answer. Okay, now let's go back to the chat. Can I share? Okay, can you please share that GPT session? By that GPT session, okay, so let's now talk about what you say and not only about what I say. So dense retrieval is just the same, Shar, as search by meaning in Pinecone. And they just call it dense retrieval to be different. Can you please share that GPT session? You mean that what it said? Your question is what it said, right? Well, let us do it this way. Let's go to ChatGPT here. And let's copy it. There used to be a way to copy that and store it at ChatGPT expense, but not anymore, I think. You can copy it, but you cannot give others that link. So I copied it all. I will put it into right here into the webin folder. And I think that's not enough permissions. So what I will do, I will prepare that, but I'll finish it later. Okay, so what chat GPT say? Send, okay, and that will be a link, but that link will have to be provided. Will be provided. So I'll show you, though not this very second. And then let's go back to chat. And Al was saying, I'm not sure if you covered before, but Google got into this at a Gemini event, and I wondered if you know about function calling with the LLM and elaborate on that. The answer is yeah, function calling. So Google does it on Gemini, but function calling is a subject of a lot of other lectures, not necessarily with Google, and it is found here. Okay, so let's find it. Here is one, and that is function calling with data extraction and LLM, and it is already converted to OWLM right here, done and accepted, so you can run it yourself. The idea is that it used to be that ChatGPT didn't do math well, but by now it says, oh, that's a math problem. Let me whip up my calculator. So that's what you give it. You give it a function that will do something that it has to delegate to somebody else. Calculator was brought just as an example, but that tells about all kinds of functions that you provide, and then it decides which function to call, not necessarily listening to you that you ask to use that one. You can add to your instructions, prompts. You can say, please use all the functions that I provided, something like that. But that's where it is. That was your question, right? Yes, that was your question. All right, guys, that was awesome. And I have some other things that I need to do. So by next time, we will continue. We'll go deeper into some of that. And I usually do this. I prepare a copy for the next time. Okay, so I start with a copy of what we did, but then I add what needs to be added here, and it will be provided. So here I take it away. Well, I'll keep it like that, but it will be my work for the next session, plus whatever new things happen. And my estimate is that 2 new things happen every time, and that is 2 new courses, at least 2 new courses every week. There was also a piece of news from Andrew Ng, and I just can't resist. I shouldn't be falling for a chat, but he talks about that Europe, and Share, you correct me if I'm wrong, but Europe puts additional privacy regulations, and as a result, they just lose on AI. So, for example, Facebook is not providing AI to them in the sense that they don't give the European countries the downloads of their llama. So I know it's above my pay grade, and I shouldn't be talking about this, but I can't resist mentioning that there are lots of interesting things going on in the world, but we are not going to discuss it. All right. So everybody, thank you very much. I'll try to do my homework. Next time, I'll give you the answers to 2 questions. And the 2 questions will be these. Here, the most important questions. So what is the difference? What is the difference between here and regular reg? And now I'm putting this question in. That's the question. That's number 1. Okay. And in general, what is the real use case focus here? Okay, that's for the next time. And now I'm saying, everybody, have a great week. Thank you for coming. And I wish everyone a great weekend and a great week and a great year. And thank you. Thank you, sir. Thank you, Juan. Thank you, Sunil.